I'm going to talk about water of crystallization. From there, we are going to look at the indicators and so on, as acid-base indicators and so on and so forth, universal indicators. Then maybe half time we are going to talk about the ionic product of water, and I think we are good to go. Still acid, still doing acid and base, and acid and base. We are going to talk about water crystallization, water of crystallization. Sorry, water of water of crystallization. Water of crystallization. So you realize that when certain substances crystallize out of any solution, when we say crystallize, something crystallizes out of a solution. Yeah, I know you understand. Normally, when the water is, for instance, if you are in the process of manufacturing, what do you call it? Salt. You realize that when the water evaporates, maybe with the introduction of heat or something, you realize that yeah, we get it is left with only the crystals, which we call the salts, and that process is what we call the crystallization, like for want of a better word. So I think that's when we see crystallization. Basically, we can look at it from that angle. Now we are talking about water of crystallization. You know, when certain substances crystallize out of solution, like when you have the salt, here we are talking about salts. They do the crystallization. The pure crystals are never obtained. So normally we don't really obtain the pure crystals. The individual molecules of the crystals are always associated with definite number of water molecules. So you realize that the individual molecules, we don't get the pure. The individual molecules we get are normally associated with water. They normally have some water contents. Rather than, instead of we getting the pure crystals, they normally have, or they normally contain some little water in it. And this water is what we call the water of crystallization. They form part of the distance, the body. And so we are not able to get the whole or the pure crystal itself. If it was to be salt, we are not able to get the pure salt and kasa. We find some little association of water molecules with the crystals we get. And that water is what we call the water of crystallization. And so therefore we can say water of crystallization is a fixed or definite number of water molecule that is attached to an ion or salt in its crystalline state. And so after crystallization, realize that we get salts. We don't get the salt in its pure state. We rather get it. We rather get water molecules being attached to it, and as a result, that water attached or that water molecules attached to the salt or the ions in its crystalline state is what we term as water of crystallization. I hope you are getting it. And so we can define water of crystallization as a fixed or definite number of water, a fixed or definite number of water molecules that is attached to an ion or a salt in its crystalline state. So an ion and a salt, when it's in its crystalline state, normally we find water molecules attached to it, and that water molecules attached to it is what we call water of crystallization. So basically, that's what we mean by water of crystallization. Now, it can also be defined as a fixed amount of water molecules which accompanies a crystal. Just as I already explained, which accompanies a crystal or which is associated with a crystal when the substance is obtained from aqueous solution. So when we say aqueous solution, we are trying to talk about any solution that has water in it or that has liquid fluid in it. That's what we call aqueous solution. So the water that accompanies a crystal when it is obtained from that water solution is what we term as water of crystallization. And a typical example is when you go to the place where they do the crystallization. The crystallization, that is where they do the salts and so on. And they take the salts from the sea. Now the sea becomes your aqueous solution. The sea becomes your aqueous solution. And normally when they take the salt out, when they do the crystallization, you still find some water molecules attached to the salt component or the crystals. And when that salt component which is attached or which are attached to the salt component is what they call water of crystallization. Now, for example, every molecule of sodium carbonate or sodium triazocarbonate salt that is crystallized from a solution normally have 10 moles of water accompanying it. And so normally, so if you see something like this, that we call hydrated. Hydrated is the same as water. So for instance, if you see something like, if you have Na, maybe Na2, CO3, then we write just as the other that I said, maybe 10 H2O. This means that there's a salt. This means that there's a salt, and there's a water. There's a 10 amount of molecules of water is attached to this salt after a crystalline or in its crystalline form. So when we see this, it just means that the salt is hydrated, or the salt has moisture or water around it, or water molecules around it. And here the water molecules is 10. And so we see this. And so this is a hydrated salt. Now, in other words, this is a washing soda. That's in its common name, washing soda. The salt has an amount of water accompanying it. Now, the iron tetraoxosulfate crystals. Normally, they also have water accompanying it. And normally, when the water is accompanying it, to show that water is accompanying it, we normally add this water component. So the 10 means that 10 molecules of water was accompanying this number of salts. So for instance, if you have Cu, a salt, when we write a salt like this, SO4 dot 5 H2O, if we have something like this, when we have something like this, means that this salt is accompanied by 5 molecules of water. I hope you are getting it. Hello, I hope you are getting it.
Yes, sir.
So salt which crystallize out of a solution. So the salt which crystallize out of a solution and are accompanied by water of crystallization are normally called hydrated salts. So last week we studied it. So this, after it's being crystallized out of a solution, that means after drying the water from it, they will still have some water molecules accompanying it. And salt that normally have or find themselves having water molecules accompanying what we call hydrated salt. And so another name for this is hydrated salt. I think last week we looked at something of that salt. Now, hydrated salt without water. So if this salt, for instance, is able to lose this water molecules, it ceases to be hydrated because now it has lost its water or the water molecules that made it hydrated salt. Now it becomes anhydrous. It becomes anhydrous salt. It becomes anhydrous salt. So, for instance, when we take away the 5H2O, when we take away this 5, this means that the salt has lost the water molecules. Then now we call this salt anhydrous. We call it anhydrous salt. That means the salt which has lost its water of crystallization is what we call anhydrous salt. Ruben, talk to me. You raise your hands. That's what we call anhydrous salt.
So, sir, how do you make a hydrated salt anhydrous?
So definitely you go through a lot of processes. Maybe some by heating. They have some by industrial purposes that maybe I may not be able to tell you, but some by heating to a certain degree. So it will go through a lot of processes. That would be normally industrial process. I hope you're getting it. But here, when we talk about the water crystal, now we are talking about water which has been taken right or we've been gotten right from what we call the solution. So for instance, if it is seawater, immediately we take salt out of seawater, or we fetch the seawater and we are able to take some of the water out and we still get some water content in the salt. We call that what do you call it? Hydrated salt. Now when we take it through the process, the industrial process, to further take away all the salt molecules accompanying what we had from the aqueous solution, which is now the sea, then we call that salt, which has nothing to do with water again, now anhydrous salt. Are you getting it? Hello, do you get it?
Yes, sir.
So that is it. So that is normally done by what do you call it? Industrial processes, either by heating or any other thing. So that is it. Please try to mute yourself, and after talking, try to mute yourself. So that is it. Now from here we are going to talk about. So initially, this was the whole of this is hydrated. Now when we take away this from it, that means we've deducted the water molecules. Now it ceases to be hydrated and now becomes anhydrous salts. Anhydrous salts. Anhydrous. And you know the hydrous still come from the hydrated. HI. So anhydrous. That means, so that is it. So now we can also consider something called after talking about the anhydrous, we can also talk about efflorescence. Efflorescence. Is it a F? Yeah, efflorescence. We can talk about efflorescence. Now, when we say efflorescence, we are saying that the process of giving off water of crystallization to the atmosphere by hydrated salt is called an efflorescence. So, for instance, if we give off water, the process of giving water to the atmosphere or giving off. And so, for instance, if you are even heating the hydrated salt, and in the process we give off water to the atmosphere, or if we decide that we won't heat it but we put it in the sun to give off water to the atmosphere, that process of giving water of crystallization. Now when we say water of crystallization, we are trying to say the water accompanying a crystal after it has been taken from an aqueous solution. When we give off that water to the atmosphere, that process is what we call efflorescence. I hope you are getting it. So efflorescence is the process of giving off water of crystallization to the atmosphere by hydrated salts. So the process of giving off water of crystallization to the atmosphere by hydrated salt is what we call efflorescence. Is what we call efflorescence. So crystals will therefore be efflorescent when they give off some of their water of crystallization to the atmosphere, whether by vaporization or by anything. Once it gives off some of its water to the atmosphere, we call it what do you call it? Efflorescence. So that process of giving water of crystallization to the atmosphere is what we call efflorescence. I don't know if anyone has any question to ask. So when finally it gives away all the water to the atmosphere and there's no water molecules, then now the hydrated salt now becomes anhydrous salts. Are we getting it? Hello, are we getting it?
Yes, sir.
Yes, sir.
And so that is the fluorescence. So fluorescence we can define fluorescence as the process of giving. So the process of giving off water of crystallization to the atmosphere by a hydrated salt. So that's what we call efflorescence. Now let's also, so efflorescence normally takes place at room temperature, with no application of heat. So it normally takes place at room temperature with no application of heat. And so it doesn't go through any what do you call it? It doesn't go through any industrial purpose or something. It just takes place. So if you have, so we just believe that as time goes by, you will lose some of your water to the atmosphere, and that process is what we call efflorescence. So normally has no heat effect on it. So that is it. Now let's also talk about deliquescence. Let me check my spellings. Let's see. Deliquescence. No, deliquescence. Now, when we say deliquescence, then we are saying that this one is more or less like the vice versa of efflorescence. You realize that some of the some of the substance, normally solids, normally absorb moisture from the atmosphere to form solutions. You realize that some of the substances, normally they are solids or normally solids, absorb moisture from the atmosphere to form solutions. That process is what we call deliquescence. So the process of a solid or substances, or the process whereby substances or solids, what do you call it, absorbs moisture from the atmosphere to form solutions, what we term as deliquescence. Is what we term as deliquescence. So even just listen, is what we term as deliquescence. Now, a solid is said to be deliquescent if on exposure to air, it absorbs water from the air to dissolve. So when it is exposed to air, it absorbs what do you call it, some of the moisture in the air to form its own solution or to dissolve or something. Then we call that, what do you call it, deliquescent, or we say that the substance is deliquescent. So you realize that even the salt, the big salt you've been using, what do you call it, the Ningo salt, a friend saying, the Pong salt, you realize that when it is exposed to air or when you don't cover it sometimes, you realize that it's, I don't know, naturally it melts sometimes, or when you put your hands in it, you feel some water parts of it. I don't know if you get it, or you feel some moisture in it. How many of us have noticed that?
I have.
You even see some water. That process is what we call, or in that case, that's the salt becomes something called a deliquescent substance, or it becomes deliquescent. Mm. It absorbs moisture from the atmosphere. So uh, that is it. That is it. So these are example. An example is some of the substance that do, or that has been undergoing that process. What we call some examples are sodium hydroxide, the salt. Sodium hydroxide is an example, a typical example. So sodium hydroxide is an example. Uh, Potassium hydroxide. So we can write sodium hydroxide, potassium hydroxide, magnesium chloride, magnesium chloride. What do you call it? Calcium chloride. Uh, they are all examples of substances that undergo the deliquescence, what do you call it, process, or they are all examples of deliquescent substances. So sodium hydroxide, uh, potassium chloride. So potassium chloride is PCl5, P2O3, potassium hydroxide, iron chloride, magnesium chloride, calcium chloride, and calcium nitrate or nitride. They are all part of, or they are all examples of deliquescent substances. I hope you are getting it to this point.
Yes, sir.
Now we also have that substances that also still do the same process. That means they absorb moisture from the atmosphere, but the moisture is not enough for it to dissolve. I don't know if you are getting it. The liquescent, these are substances that absorb moisture from the atmosphere, and the moisture they absorb is enough for it to dissolve in it, or it's very enough for them to be for them to dissolve. Now, in this one we are going to consider, they absorb water from or moisture from the atmosphere, but the moisture they absorb is not enough for them to dissolve. And these substances we group them under something called hygroscopy. Hy, hygro, hygroscopy or hygroscopic scopy. Hygroscopy. These are like the deliquescents. They absorb moisture from the atmosphere, but the moisture they absorb are not enough for dissolving. So we can say as a process whereby a substance absorbs moisture from the atmosphere, but not sufficient for it to dissolve. Let me take it again. It's a process whereby a substance absorbs moisture from the atmosphere, but not sufficient for it to dissolve. So all these, the liquescence is a process, efflorescence is a process, hygroscopy is a process. Anhydrous salt is not a process. It's a finished product. Let me put it that way. After water of crystallization has been taken away. Water of crystallization is not a process. Now, hygroscopic substances are not processed, but they are substances that undergo the process of hygroscopy. I don't know if you get it. The liquescent substances are products or are substance that undergoes the process of the liquescence. So hygroscopy is a process on its own, where substances absorb atmosphere moisture from the atmosphere, but they are not enough for it to dissolve, or they are not sufficient for it to dissolve. Are we getting it? Ruben, your hands is up. You can ask the question now. Now, examples of hygroscopic substances are examples of hygroscopic substances. Examples of hygroscopic substances are copper oxide, CuO. Copper oxide is one example of hygroscopic substances. Copper oxide.
So, sir, please. So, is hygroscopy a type of delinquency or what?
I don't want to say it's a type of delinquency. I say they what do you call it? They perform similar tasks. Let me put it that way. They all do similar things, or they are related. But I won't say it's a type. I'll just say it's something on its own. They are all, because basically they are all sorts. The substances that falls under them, they are all sorts. So definitely, they one way or the other, they have similarities. I won't say it's a type of it, but let's say it's a brother of the liquescence. I don't know if you get my point. Do you get it? Hello. So let's say it's a type of it's a brother of it. So examples of hygroscopic substances are CuO, copper oxide, CuO, calcium oxide, CaO, CuO, calcium oxide, CaO. We can also talk about triazonitrate, sodium triazonitrate salt, which is NaNO3. NaNO3, sodium triazonitrate salt. So NaNO3. NaNO3. We can also talk about concentrated sulfuric acid, concentrated or Conc H2SO4. Conc H2SO4. Conc H2SO4. Conc H2SO4. We can talk about that. Conc H2SO4. Now we can also talk about ethanol. Ethanol is C2H5OH. Ethanol is a family of one of the families of an alcohol, or is an alcohol. Let me put it that way. C2H5OH. C2H5OH. We have 10 minutes to end. We will start again and complete. C2H5OH. So that is it. These are one or two things. For instance, calcium oxide absorbs water from the air to form a solid calcium hydroxide. So calcium oxide absorbs moisture from or water from the air to form what we call calcium hydroxide. And calcium hydroxide is Ca into bracket OH bracket close to calcium hydroxide, which when we divide, we are going to get Ca plus 2OH. That's what we are going to get. That's when we are to split them into two. That's what we are going to get. That's what we are going to get. So we've studied normal salts, acid salts, double salts, complex salts. We've studied all these things the other time. Now let's talk about conductivity. Conductivity and this thing. When we say conductivity, we understand the ability of a substance to conduct electricity. Normally in this thing, conductivity. So the ability of a substance to conduct electricity is what we call conductivity. Now, under here we are going to talk about acid and base. You realize that water molecules or water soluble acids. When we say water soluble acid, that means these are acids that are able to that are soluble in water. Let me put it that way. Base and salts. They normally undergo electrical conductivity. So we are saying water soluble acids, bases, and salts. That means salt, acid, and base that dissolved in water are able to undergo something called electrical conductivity. And they undergo this conductivity due to the presence of and the movement of free ions of the electrodes. And so they have ions in them that, or in better still, electrodes. And when we say electrodes, substances that conduct electricity or that allow the passage of electricity to pass through them. And so because of the presence of the ions and so on and so forth, they are able to conduct electricity. And they are therefore electrolytes. You know, when they are therefore electrolytes, when we say electrolytes, electrolyte is a water medium or a liquid medium that allows what you call conductivity, that allows connectivity. For instance, when you blast your batteries, the big Tiger Watt battery, you realize that it has that slimy or that liquid type chemicals in it. That this thing is what is an electrolyte. It's a liquid system, but it allows what you call electrodes and ions and all those things, or it allows what you call connectivity. So that we call electrolytes. Now, that's that. So we are saying that some acids which are normally soluble in water are able to conduct electricity, and because they have ions and electrodes in them, so that is it. So they're able to conduct. However, we have that, or we have some to that doesn't conduct, and those that does not conduct will be grouped under the weak electrolytes or the non-electrolytes. Now, chemical reaction normally take place at the electrodes in which electrons are either lost or gained. So you know, when we talk of ions, we are talking about either losing an electron or gaining an electron. That makes it an ion, or that makes it become an ion. And so normally the chemical reaction in the solution or in the electrolyte solution normally takes place when the electrodes here will be the ions in the distance, when they either lose or gain electrons. And the chemical process is called electrolysis. That process of the chemicals, the process of that chemical reaction that takes place when electrodes either gain or lose electrons are what we call electrolysis. What we call electrolysis. Now, electrolytes are compounds which, when molten or in aqueous solution, conduct electricity. So just as I explained in a previous lesson, I said electrolytes are normally compounds, liquid compounds, let me put it that way. And when they are in aqueous solution, they normally conduct electricity. And so they are conduct electricity. An example is aqueous hydrochloric acid, HCl. Aqueous HCl is one example of an electrolyte. One example is Cindy. Another example is, what do you call it? Another example is, what do we? Another example is sodium hydrogen tetraodosulf. Hey, what am I saying? Sulfuric acid, H2SO4. Is one example of solutions or electrolytes. These are examples of acid that conduct electricity. Now let's consider examples of the bases that also conduct electricity. Example of base that also conduct electricity. Now we can consider sodium hydroxide. Sodium hydroxide in its aqueous state. Sodium hydroxide in its aqueous state, or aqueous sodium hydroxide. We can talk about that. We can also talk about NH3, ammonium in its aqueous state. NH3 in its aqueous state. These are a few examples of bases in its aqueous state that are able to conduct electricity or that supports conductivity. Now we can also move on to further talk about salts that also, when in its aqueous state, are able to conduct electricity. And a typical example is sodium triosonitrate acid, nitrate salt. So NaNO3, sodium triosonitrate salt. NaNO3 is one example of salt that conducts electricity or that allows conductivity. Now we can also talk about potassium chloride in its aqueous state, or aqueous potassium chloride. Aqueous potassium chloride. Aqueous potassium chloride. Aqueous potassium chloride. These are all examples of salt that also conducts electricity or allows or that are termed as electrolytes. That means allows electricity or conductivity. Now we can also talk about, as we've been able to talk about electrolytes, we can now talk about non-electrolytes. We can talk about non-electrolytes, and definitely we know that non-electrolytes will be the vice versa of electrolytes. We are saying that non-electrolytes are normally compounds which do not conduct electricity since they do not contain ions. So non-electrolytes are normally compounds, whether in a solid or aqueous state, that do not conduct electricity, and as a result of they not containing or they not having ions in them. So that is it. An example is ethanol, kerosene, trichloromethane, trichloromethane. That means methane with 3 chlorines. Hydrogen chloride dissolved in methyl benzene, and tetrachloromethane. These are one or two examples of non-electrolytes. You can just kerosene, ethanol. You should just remember all these things. These are all non-electrolyte. That means they are compounds that do not support electricity, or they are not conductors of electricity. Now we can also consider strong electrolytes. Now immediately we see the strong, we already know what electrolytes are: compounds that support electricity or that conduct electricity. So immediately we say strong electrolyte, then we are saying that they are good conductors of electricity. So strong electrolytes are good conductors of electricity, and it's just as a result, it's just because they ionize completely in aqueous solutions, and as a result they produce many mobile ions. Because they ionize completely in aqueous solution, they produce many mobile ions. When you dissolve more, you produce more ions, and as a result you conduct more because you produce more ions. The class will end in about a minute time, so when it ends you start again. An example, and so definitely the weak electrolytes are those poor conductors that do not conduct electricity to the maximum. They are poor conductors, and as a result they do so because they ionize partially. So they produce fewer or less ions. They produce fewer or less ions.